Good morning and afternoon, everyone. A very warm welcome to today's webinar, The Use of Foam Materials in EV Battery Applications. My name's Aaron McIver, Head of Marketing and Insights at Zotefoams, and I'll be your host for today's session. Today's presentation will run for approximately 45 minutes, beginning with a welcome and introduction to Zotefoams from Ollie Ridd, our Global Commercial Director. Following that, we'll then move into the main presentation, which will be delivered by Sam Norman, Head of Business Development for our Transport and Smart Technologies vertical. Sam will also be joined by Ellie Howland, one of our brightest application engineers working in this space. So you'll be thrilled to hear that we have a packed agenda for you today, and we'll be covering a range of topics that are particularly relevant to the rapidly growing EV battery market. We'll kick things off with an overview of Zotefoams' new market focus strategy and our ongoing innovation efforts. We'll then step into the current trends in the EV battery sector, and then we'll take a deeper dive into how supercritical foam materials can be used to deliver outstanding performance across a range of different EV battery types. We'll also be covering a detailed comparison of commonly used materials, focusing on parameters such as compression performance, thermal insulation, and vibration protection. Finally, we'll take a look at Zotefoams' innovative foam solutions for battery applications. And at the end of today's session, we'll open the floor to a live Q&A with all speakers. But first, a few housekeeping notes. All attendees have been muted and cameras are off by default. If you'd like to ask a question at any point, please use the Q&A or chat box. We'll address as many of these questions as we can during the Q&A section. Finally, the webinar is being recorded and will be available on our YouTube channel following the webinar, so feel free to revisit and share it with colleagues. I'll be back at the end to moderate the Q&A, but for now, I'll hand over to Ollie to get started. Ollie, over to you.
Great. Well, thank you, Aaron. And it's fantastic to have all of you here. So good morning, good afternoon. My name is Oliver Ridd. I'm the Group Commercial Director at Zotefoams. 2025 is a pivotal year for us at Zotefoams, as it marks the launch of our new strategy. So we are shifting away from being a product-led business into one that is industry-led, placing our customers, our partners, at the heart of everything that we do. Our aim is to better understand what truly matters to our customers and enable them to deliver greater and greater value over time in their supply chains and to their end customers. We're building on over 100 years of heritage in innovation, in manufacturing excellence. And Zotefoams' history is full of firsts, from being the pioneers of supercritical fluid foaming technology through developing solutions that have transformed industries with our customers. You're now going to see a short video that says a little bit about our business and helps to explain how we work with our customers to push the boundaries of material performance.
The world is changing, and the need for high-performance, sustainable materials has never been greater. Our specialist foam products are already an essential part of future technologies. Lighter, stronger, safer, smarter. They allow you to go harder, go faster, go further, go greener, go forward together. For over a century, we have been a world leader in supercritical foams. From the dawn of the first industrial foams to today's cutting-edge supercritical fluid technology, innovation has defined our market-leading product portfolio. And our unique manufacturing processes eliminate harmful chemicals, reduce waste, and are more sustainable every day. With a global manufacturing footprint, we ensure critical high-performance materials reach our global customers worldwide. We operate in high-value, fast-growing markets, where our advanced materials enhance performance, safety, and sustainability. By using our advanced technology, we replace existing heavier materials, such as polycarbonate, to help reduce fuel burn. We are powering the shift to cleaner transport with high-performance foams that insulate EV batteries, reduce vehicle weight, and create high-specification interiors. We're also helping to build a greener future with advanced insulation for manufacturing, industrial, and net zero buildings. We are creating lighter and more sustainable packaging and product protection made with recycled materials. We push the boundaries of human potential, from helping to set world records for elite athletes and personal bests for everyday sports to life-saving medical applications. Our materials enhance comfort, protection, and performance. Our products are already an essential part of future technologies. As markets evolve, so do we. We are Zotefoams, and we are expanding beyond the core.
Great. Now, hopefully that gives you a bit of a view of what we're all about here at Zotefoams. And now I'd like to tell you a little bit more about this market focus that we have. And we are divided now into 3 key market verticals, and they cover consumer lifestyle, transport and smart technologies, and construction and industrial. And within those 3 market verticals, we have seven priority industries that we are laser focused on as a business. Now, given the topic today, we are within the transport and smart technologies realm, transport and specifically around the EV battery space. It's a highly evolving industry at the moment. The automotive sector as a whole, we have quite a lot of experience in and a real history with. And this is an area that we are now developing more and more with multiple customers. And we're very excited to be able to talk a lot more about some of the solutions that we are bringing to market and the support that we are able to offer our customers. So you're going to hear now a little bit from Sam and from Ellie, 2 of my colleagues. So I'm going to pass over to them now. Thank you.
Thank you, Aaron and Ollie, and good morning and afternoon, everyone. And thank you once again for joining. My name is Sam Norman, and I'm Head of Business Development for our Transport and Smart Technologies market vertical here at Zotefoams. So I'm going to start by taking a look at a macro market overview of the EV battery market. Now, it's obvious that the market is big. The global EV battery market stood at around $100 billion in 2024, with total foam use in all battery applications standing at around 1.2 billion for the same period. Now, given its vertical integration to key raw materials used in the production of batteries, as well as low production costs, unsurprisingly, Asia and predominantly China leads the way with a 71% market share of EV battery manufacturing in 2024. Continental Europe has an 18% share, with North America at 11%. And despite current headwinds in EV uptake, both in North America and in Europe, both regions are still heavily investing to increase battery manufacturing capability, and examples of which can be seen by VW's aim to build 6 manufacturing factories in the EU by 2030, and Nevada, which currently hosts the world's largest mega factory by land area, and this factory is focused on the production of lithium-ion cells, EV components, and battery packs. So despite the challenges, the industry continues to grow. The compound annual growth rate of the global EV battery market is consistently projected in the range of over 10%, so plenty of growth to come. It's also worth mentioning at this point that when it comes to foam selection within the market, it remains fragmented, and selection or design authority is largely project specific. There's currently no industry standard material for a lot of the applications we'll discuss in later slides, but this presents an opportunity for a company like Zotefoams, where we're able to utilize our unique manufacturing technology and provide cutting edge solutions for the battery market. So before we talk about foam uses and drivers for use, let's take a brief look at the 3 main battery types, starting with cylindrical. Cylindrical batteries are typically lowest cost, however, have the purest packing efficiency, and the foams used in these cell types are typically injectable foams. Moving on to pouch cells, they typically have large dimensional changes during charging and discharging, however, have high energy density and packaging efficiency. Softer foams with strong compression performance tend to be used in pouch cells. Finally, prismatic cells are a popular choice for many new projects globally, and this is due to smaller dimensional changes during charging and discharging. Also, they have good packaging and size profiles. Typically, a firmer foam is required for this cell type. So we're now going to look at the main use areas for foam using the example of a prismatic cell design. And there are four main uses within and surrounding the battery. So the first, foam is used for thermal management to help regulate battery temperature and protect from vibration. Secondly, foam is widely used between the cells as cell dividers and compression pads. Foam pads are integral in applying a pressure to extend cell lifetime, protect from vibration, and allow cells to expand and contract safely. Thirdly, foam is also used as a cushioning material to protect against vibration and impact, whilst maintaining structural integrity. And finally, foam is often used as a sealing or gasket material to help protect the battery from external debris and fluid. So with that, I'll now hand over to my colleague Ellie to explain in a little more detail the key concerns and drivers for foam use in batteries.
Thanks, Sam. I'm now going to dive a little further into the drivers for foam use in the 4 application areas that have been highlighted, starting with thermal management. In order to get the best out of the battery system and maximize the range of the vehicle per charge, it's very important that battery cell temperature is maintained in a narrow range. Using thermally insulating foam materials can help protect the battery pack from fluctuating external temperatures and maintain that cell temperature. Overheating batteries can experience thermal runaway, which is a major safety concern, and combining insulating foams with flame-bearing materials can form part of the protection against this when used in battery packs. Another way that thermal runaway can be triggered within battery cells is via physical damage. So the use of foam materials in cushioning and impact detection is an important safety measure to protect against knocks and vibration so that batteries are not damaged. Short-circuiting of battery components due to water ingress is another safety concern for battery users. Foam materials can be used in seals and gaskets to effectively seal sensitive components from wet weather. And finally, battery lifetime is key from a reliability and cost of ownership perspective. It's known that applying a controlled pressure to battery cells during their lifetime can reduce the rate of swelling that occurs as the batteries age, as well as improve contact between components in the cell. This extends their lifetime and improves performance. Foams are selected to provide this stack pressure, as well as allow any changes in battery dimensions as it charges and discharges. OEMs and battery manufacturers have a long list of requirements for the foam materials that are used within their packs. This can include consistent compression deflection performance, thermal stability, fire retardants, and many more. The most critical requirements are closely linked to the cell chemistry that is used. And the 2 main cell chemistries that we'll consider are NMC and LFP type cells. NMC cells have a higher energy density, which is ideal for performance and long-range vehicles, but they do come with a higher cost and greater safety risks. Materials that are used alongside NMC cells typically need high temperature resistance and flammability performance. LFP cells have a lower energy density compared to NMC, but they are much lower cost and have greater stability and safety. This has led them to become increasingly popular with a very large market share within the Chinese market. The compression performance of the foams that are used with LFP cells is critical to cope with the large number of charge and discharge cycles and provide stack pressure. The flammability of foam materials used with LFP cells is less of a concern, but competitive cost is important.
Thank you, Ellie. So now we understand a little bit more about why foam is used. We're going to take a bit of a deeper look into the materials typically used currently. And there are 8 major considerations when selecting a foam material for use in EV batteries, which can be seen around the diagram on this slide. And what will become clear is there's no perfect solution, and each OEM must decide what properties are most critical depending on the project, cell type, and other factors. So with that, I'll now hand back over to Ellie to go through each material in a little bit more detail.
Thank you, Sam. Now I'll go through some commonly used materials for the foam applications in electric vehicles. As Sam mentioned, each will have its benefits, and going back to the previous slide, selection will depend on cell chemistry and other system considerations. Starting with polyurethane foams, these are widely used for their compression performance and low cost. However, they don't have the wide temperature range or flammability resistance of some other solutions. Encapsulated aerogels are materials with very low thermal conductivity and high temperature resistance. However, they must be completely wrapped to prevent material shedding, and are also known to settle over time, leading to some inconsistencies in their thermal performance. Silicone foams have excellent compression performance and high temperature properties, but they can be very heavy and costly to use, so these properties must be balanced. PVDF foams are widely used in the aviation sector due to their excellent flammability performance and low weight. However, they are pretty expensive and will melt at temperatures expected in extreme thermal runaway events. TPE foams are lightweight and have excellent compression and recovery performance for many cycles, so they're well suited for use with LFP type cells. However, their fire retardant grades must be developed if required. Polypropylene foams are widely used in China due to desirable compression curve as well as low cost. However, again, their temperature resistance is not quite as high as that of silicone or aerogel, and resilience in cyclic compression is not as good as for TPE foams. Polyethylene foam is another low weight and cost-effective solution, but again, the temperature resistance is not high compared to silicone or aerogel. Looking at all the materials in this one diagram, we can see that different material options score higher for different requirements. No one material satisfies all of them. Depending on the project priorities, cell format, cell chemistry, the best material for each application can vary widely. Sometimes foam materials will need to be made into a composite solution with layers such as mica or glass fabrics in order to meet more of the requirements, such as flammability. And with that, Sam will now talk you through Zotefoams' role in innovation for the EV battery sector.
Thank you, Ellie. So at Zotefoams, we already have a really diverse product portfolio with a number of our current materials offering a range of the desirable characteristics that Ellie's just talked about for use within EV battery applications. And you can see a few of them in this slide. All of our materials are lightweight, have low thermal conductivity, and can be easily thermoformed or cut to shape if required. And depending on the grade selected, we can offer solutions where compression performance, temperature, and flammability constraints are important. And innovation really is at the heart of what we do here at Zotefoams. And looking beyond our current material portfolio in this market, we're utilising our unique manufacturing capabilities and actively working with a number of key players in the e-mobility industry on multiple new polymer developments to help with the next generation of material and battery applications. And the video on the next slide will introduce Zotefoams' innovation arm in a little bit more detail.
If you look at our history, it's really a story of firsts. First, to create supercritical fluid foam. First, to produce closed cell materials. First, to manufacture cross-linked polyethylene foams. And we didn't stop there.
Our foams have literally transformed industries, like making planes lighter so they burn less fuel, or helping athletes push performance further with insane energy return.
And all of this comes from a surprisingly simple process. We take a polymer and shape it, either into a block or a 3D shape. Then we put those into a high-pressure autoclave, dissolve nitrogen borrowed from the atmosphere into them, then, under controlled conditions, we expand it into foam.
Sounds simple, but not even close. It takes serious expertise, technical know-how, and decades of research to make it work like this.
And we don't just stick to what we know. We're always experimenting. New polymers,
New applications,
new markets.
because great innovation happens through collaboration.
We work with our customers,
Understand their challenges,
engineer solutions.
and that's how we keep pushing the boundaries of material performance.
But it's not just about performance.
It's about doing it better,
Smarter.
more sustainably,
We're constantly re-engineering our products to be greener.
more efficient.
That's innovation.
That's Zotefoams.
And we're expanding beyond the core.
So one example of Zotefoams' continual focus on innovation is our development work on our TPE range of materials under the brand name Zotec T, and this is our thermoplastic elastomer range of materials. We're able to adjust properties such as density to help us meet specific customer compression requirements, for example. Zotefoams' unique range of resilient TPE closed cell foams accommodate dimension changes during charging of cells and provide stack pressure, which can contribute to increased lifetime of cells. Other advantages of our Zotec T material include the ability to maintain mechanical performance over a wide temperature range, and as with all of our materials, high purity and consistent performance as a result of Zotefoams' unique manufacturing process. Another new addition to our material portfolio is our EcoZote polypropylene foam. Polypropylene foam is already widely used in the Chinese EV market with the likes of BYD and S-Volt, and this is largely due to its flat compression curve and relatively low cost. This is a material we think could be really interesting to the European and North American markets. Polypropylene foam is also non-cross-linked and therefore fully recyclable. So in summary, the EV battery market is huge and is growing. Europe and North America do remain significant markets despite China dominating. And foam really is a key material in this market, used both in the functionality and the protection of the battery. Requirements vary from project to project when it comes to foam material selection in batteries. Hence, Zotefoams developing a material portfolio to help cater for varying needs in this market. Innovation is at what the core of Zotefoams do, and we believe innovation is key in this market to continually evolve and grow to stay ahead. Thank you very much for joining our webinar today. We'd be happy to answer any questions. And with that, I'll hand over to my colleague Aaron, who'll be moderating our Q&A session.
Well, thank you, Sam, Ellie, and Ollie. Really insightful presentations from you all there. And I also know that the audience have really appreciated that, as they're super engaged with lots of questions to follow up on. So with that in mind, we're going to move to the Q&A section of the session. And I'm going to ask all my colleagues to join the stage, which I think we've already done. Just a reminder to those watching, there's still time to get your questions in. Just use the Q&A panel on the platform. All right, and for our first question session, let's start with something that I know each of our panel members will definitely have something to say. Question number one, I'm going to direct this to Ellie first. What's the main difference between foams manufactured by Zotefoams and chemically blown foam? Definitely a topical one. Ellie?
Yeah, so you will see that the video of our process previously, that we use high pressure nitrogen in order to foam our materials. What that brings to our products compared to foams that are blown with chemical blowing agents is a consistent, durable product. So throughout the sheet, you're getting material with the same density, the same mechanical properties. So for any applications within batteries where you need that consistent performance in every single part you're making, that's really important. What we can see in some chemically blown foams is density profiles throughout sheets of material, leading to different compression properties depending on where you cut your part from the sheet. So if you're trying to hit very specific compression specs, for example, compression pads between cells, then having that consistency in performance is really important. On top of that, you're not getting any chemical residues from any blowing agents within the foam. So our foam is very pure, low odor, low volatiles. So any sensitive components won't be contaminated by that either.
Great. Sam, did you have anything to add to that? I know you'll definitely have something to say.
Yeah, it's a great answer, Ellie. I think that covers some of the key properties that make our materials so attractive. I think another thing I'd just add to that is our technology also allows us to foam polymers that typically couldn't be foamed in other processes. So that allows us to really add different polymers to our portfolio, and also allows us to reach densities that maybe couldn't be reached using other processes. So that low density aspect is really a product of our unique manufacturing technology as well.
Awesome. I'm going to shift gears slightly and talk about the actual market. And Sam, I think that's probably one for you. Could you expand on the demand differences for foam types between Europe, North America, and China? There's probably a much more detailed answer to this, but do you have anything to say off the top?
Yeah, of course. I mean, I think it's largely driven by the cell chemistry and the volume of production. So I think, you know, we're certainly seeing the LFP cell chemistry type lead the way, growing in Europe and North America, but certainly leading the way in China. That's typically, as Ellie explained so well during the presentation, typically the need for less flame retardant properties within the materials. It's more a shift towards compression and cost, compression performance and cost. So certainly that is an area that we're seeing expand in China, and we're seeing more of that come over to Europe and North America, I'd say. Where we're looking at the higher performance NMC cells, that's where we're seeing differences in the types of foams and combinations of materials needed if, for example, a cell divider has to withstand or be able to withstand an event of thermal runaway or thermal propagation. To be higher end or combination of materials used in those types of cells, I'd say.
Great. And just to extend that in terms of the actual application as well, in terms of installing foam, you mentioned that, Sam. A question about installing foam into batteries. Is glue used? It's possibly a question for Ellie.
Yeah, I know, I can take that one. Yeah, certainly. I mean, there's a lot of different ways that these stacks are created. Typically, there will be some sort of pressure-sensitive adhesive used to bond parts together. Sometimes that is just as an installation step and isn't necessarily something that's then permanently required. But short answer is yes, adhesives are used within the battery assembly.
Awesome. And in terms of the market we've been covering today, another question is about the focus we've had on EV batteries. What about the wider energy storage market? Does Zotefoams see that as an opportunity as well as EV batteries?
Absolutely is the short answer. I mean, our material can certainly be considered for applications in the wider energy storage market. Clearly, the focus of today's webinar has been e-mobility applications, where we do have a strong fit based on a number of factors we've already discussed. One being the ability to produce extremely low density foams, which is advantageous to help contribute to weight reduction of electric vehicles. But many of the other factors and properties of our materials, such as the insulative properties of our materials or performance at cold temperatures of Zotefoams material, for example, which is attractive for maintaining vessel temperatures in hydrogen storage applications. So depending on the properties the project is calling out for, there's definitely materials within our portfolio, I'd say, that could be considered for other energy storage applications. So, if there's anyone on this webinar that has any, specific questions on a specific project, please do reach out to us following this event.
Excellent. And just to say, team, there's also quite a few non-questions, more comments saying that they're really enjoying the webinar. So thank you for those the comments and pieces of feedback. I'm sure the team appreciate that. A lot of interest in who we're currently working with, right? I don't know we're going to be able to say too much there, but perhaps a combination of Ollie and Sam, can you give a flavor of who we're working with in the EV battery space? Ollie?
Yeah, so I think at the moment it's a real mixture between some of the major OEM players, so some of the big battery producers globally, but also some of the smaller players that are then integrating components as part of the systems. And we are starting to have conversations with the energy storage and other battery storage applications as well outside of EV. Obviously can't name names here, but we've got quite a lot of ongoing projects now. Sam, I don't know if you want to add.
No, I think that covers it. I'd say, yeah, there's lots of exciting projects ongoing at various points of that supply chain, from OEM level down to tier 1, even tier 2, and also opportunities for partnership as well. As we've seen during the course of this presentation, depending on the requirements, sometimes one material by itself can't do the full job, depending on what the requirements are. So we're having discussions on lots of interesting partnerships with other complementary materials to foams, which is interesting. What I'd say is it takes up a lot of my time, so there's lots of activity there, which is brilliant.
Excellent stuff. Thank you so much for that, guys. A question about where we're manufacturing. Obviously, we have a global manufacturing footprint. Where are we manufacturing foams that will be relevant to these applications? Just in Europe, or Europe, North America, and elsewhere? Sam, Ollie, do you want to say a word on that one? Sam?
Sorry, Aaron, my connection cut out for a second there. Could you repeat the question?
Yeah, sure. It's a question about where we're currently manufacturing materials for this market. Obviously, given it's a global market, some interest in where we're manufacturing and how close we are to customers.
Absolutely. So I'd say, as a general comment, Zotefoams have an excellent global reach. So our main manufacturing hub is headquartered in the UK, just south of London in Croydon. We also have a central European facility in Poland, manufacturing facility there. We have a manufacturing facility in the US as well, which we've just, not just announced, but we're well on the way with a CapEx investment that allows us to expand on our manufacturing capability in the US to serve local markets there. We have a conversion facility already in China, and you may or may not have seen a recent investment announced, which is bringing online some more manufacturing capability in Asia as well. So I'd say we've got a pretty good global reach and spread to be able to service various markets.
I might just add a little bit to that as well, Sam. I think given what's going on in the world at the moment as well, we're very much trying to take the approach of manufacturing close to our customers. So wherever we've got an opportunity, we will try to produce that product as close to the end customer or the tier 1 or integrator as possible. So we have global reach at the moment. As time goes by, we will shift to try to suit the market need and where the customer is with where we are producing the product as well.
Yeah, excellent. Stepping back into a more technical question, and one that's more related to the EV battery manufacturing space. I know, again, there'll probably be some interesting comments from our team in relation to this, because I know it has been a particularly hot topic. Are there clear standards for EV batteries in relation to materials that are specified into EV batteries?
I guess that's on for me then. Yeah. So there are standards out there, global standards and specific Chinese standards as well, when it comes to battery safety and the performance of, battery packs and the vehicle as a whole. When it comes to individual materials, there's not a consensus, I would say, on exactly what is required from the material itself. It will depend on what that specific OEM or battery pack designer has decided is required in order to meet those sort of overall standards for the pack and the vehicle. So I think you probably saw it mentioned on a couple of our slides. There will be some people that will ask for quite stringent flammability requirements, for example, like UR94 V0, but that isn't something that is a set standard for materials that are used in packs. It will be a case-to-case example. So I guess short answer is no, there's not a set material standard. We do see a lot of different requirements from different customers, but there are standards when it relates to the pack as a whole and the vehicles involved.
Excellent, thanks for that, Ellie. Still staying with the materials, but to switch gears to talk about sustainability, what role does more sustainable materials play, or I think specifically they're asking about recycled and recyclable materials play in this EV battery space? Ellie, sorry to throw it back to you, but I feel as if that's one for you.
Yeah, so we make quite a large range of materials, as you've seen. Some are cross-linked, some are non-cross-linked. When it comes to direct recycling, the non-cross-linked materials are easier to recycle. That being said, our whole range of materials are typically lightweight and a lot more lightweight than competitive solutions. So there you are reducing the weight of your overall system, reducing the amount of polymer that you're using in the first place. So saving energy over time, which relates to reduction in emissions, depending on how that energy has been produced, as well as reducing the initial polymer quantity that you're using as well. Something else to say about recycling is relates back to that question previously about adhesives. There are questions over how easy it is to actually disassemble all these different parts from battery packs as well. So that's something to consider.
So the afterlife, material processing, etc. Excellent. Well, I think actually we are now at the end of our questions. We have, just to check, I think we have covered most of the questions. At least we covered the questions that have possibly been asked duplicate as well. So with that, we are, time is marching on. We are just about running out of time. Clearly, thank you to everyone who submitted the question. If we didn't manage to answer your specific question, then please do feel free to follow up after the webinar. Of course, very happy to connect on a more individual basis. Before we go and to wrap things up and close out today's webinar, I'm going to hand back to Ollie Redder, Group Commercial Director, who's going to leave us with a few final thoughts. Ollie, over to you.
Great, thanks, Aaron. Well, thanks to everyone. So thank you very much for joining the webinar today. We've got a really exciting time ahead of us. So as we put more focus into industries with the best opportunities for growth, we offer engineered solutions to the customers. And as you've seen today, we've got both a really long heritage of innovation and best-in-class products that have transformed industries. Our technical colleagues work with our customers to help them increase performance, reduce weight, and win in their end markets. We look forward to speaking with many of you as well after this event to understand and support with your applications. Thank you, and I hope you have a great rest of your day.
Thank you.